I'm going to talk about Green's theorem, particularly what it is and why it's used. Green's theorem involves evaluating a closed curve that encloses a region of a vector field without cutting or crossing over itself along the path. The region is enclosed by such a curve in a plane within the vector field. It equals the double integral over a region contained by the curve, and it differs from a line integral where the dot product of the force and the path, or the distance traveled along the path, are evaluated, in that it represents the work done within the area contained by the path. So the curve must be closed for Green's theorem. Another difference is that the vector field must be non-conservative when using Green's theorem. The work done is essentially equal to the work done in the area contained within the curve, and is found by evaluating the boundary curve with the formula or equation used to evaluate the work. i.e., the boundaries of the integral represent the boundaries of the region, and is used along with the equation to evaluate the value of the work. The benefit of using Green's theorem is that the curve can be evaluated at once, and it eliminates the need to evaluate the curve one segment at a time. The curve that moves in a counterclockwise direction represents a positive orientation. The curve could be of any shape as long as it's simple, again, not crossing over itself. So it could be a curve like this, and the arrows here represent a counterclockwise orientation, which is a positive orientation. It could be like a square. And here, the arrows are written to represent movement in a clockwise direction, which represents negative orientation. It could also be written circular motion, but the shapes, and that's my best effort at a circle, but the regions can vary greatly, as long as they are a simple curve, simple closed curve that don't cross, that has a path that doesn't cross over itself, and it's within a non-conservative vector field.